Hello students, today we're going to look at starting chapter 10, look at 10.1, which is graphing equations in the form y equals ax squared plus c. And the ax squared and the c look familiar to us because that's part of the trinomials that we've been dealing with, and we're going to get to more of those trinomials, but now we're going to start pretty easy with ax squared plus c. So let's look at some vocabulary. First of all, a quadratic function. A quadratic function is a non-linear function that can be written in the form of ax squared plus bx plus c. You see, that's the whole trinomial thing, where a does not equal 0. Every quadratic function has a U-shaped graph called a parabola. Now, you can call it parabola if you want to, but most people call it a parabola. Now, when we graph a parabola, the lowest or highest point on the parabola is the vertex. And you see a picture of a parabola right here. And you see this parabola, and you see 0, 0. That would be the vertex because that's the lowest point. Now, if it was turned upside down, like this, then 0, 0 would be the highest point, and that would make it the highest point on it. So that's why we say it could be the highest point or the lowest point on the graph. And you're looking at a picture of the parent function of a quadratic function. Okay? The most basic quadratic function, the parent function, is y equals x squared. The line that passes through the vertex and divides the parabola into two symmetric parts is called the axis of symmetry. For the parent function, this line, or the axis of symmetry, is x equals 0. I'm going to trace over it. This is my axis of symmetry, and because it's the parent function, it's actually the y-axis. And the equation for the y-axis is x equals 0. So you're always going to have you'll always have a vertical line that is the axis of symmetry of my parabola. The vertex of this parent function is the origin, so it's 0, 0. It's important to remember this because you're going to start comparing other functions to the parent function, and the parent function is always going to have x equals 0 as the axis of symmetry and 0, 0 as its vertex. So let's graph some quadratic functions. I'm going to fold my paper in half. And here we're given a quadratic function of y equals 1/2 x squared. Well, I'm given all of my x's, so I need to plug in those x's to figure out what my y values are. So if I plug in -4 for x, -4 squared is 16, and 1/2 of 16 would be 8. And then -2 squared is 4, and half of 4 is 2. 0 squared is 0, and half of 0 is still 0. 2 squared is 4, and half of 4 is 2. And then 4 squared is 16, and half of 16 is 8. Notice again the symmetry in this. So let's graph it. -4, 8. -4, 8 is right there. -2, 2. 0, 0. 2, 2. And 4, 8 is right there. And we're going to graph this so it is a smooth curve. And it takes a little practice drawing smooth curves. I still haven't perfected it, but I'm doing okay. So that is my parabola. Y equals 1/2 x squared. And I bet you're wondering what the domain is, because you know we always ask that question. The domain is going to be all real numbers. But the range, the y values, is y is greater than or equal to 0. Because if you look on the y-axis, my lowest point is 0, and everything else on the y-axis would be greater than 0. So that's why the range is y is greater than or equal to 0. I'm not going to do the next example with you. I'm going to let you do that one on your own. You're going to notice already that it might look upside down. That's okay. but that's going to be part of your practice problem. The next part of this that we're going to do is we're going to graph another one, y equals x squared minus 2. So that was where the ax squared plus c comes in, ax squared and c. And so I'm going to plug in my x values that are given to find my y's. And so negative 2 squared is 4, 4 minus 2 is 2. Negative 1 squared is 1, and 1 minus 2 is negative 1. 0 squared is 0 minus 2 is negative 2. 1 squared is 1 minus 2 is negative 1. And 2 squared is 4 minus 2 is 2. So now I'll graph it. Negative 2, comma 2, negative 1, negative 1, 0, negative 2, 1, negative 1, and 2, comma 2. There it is. So I'm going to draw my smooth curve. And I always put arrows at the end. I think I forgot to put arrows on the other example because they're always going to continue to rise. So there's my parabola. My domain is still all real numbers. And my range is y is greater than or equal to negative 2, because that's where my vertex is. And my vertex is 0, comma negative 2. That was just free. And you're going to graph this second one on your own as a part of your practice problems. There's one other thing we're going to look at, and we're going to look at comparing the graphs that we do to our parent function. Okay? So I'm going to try to keep that graph available because we would like to use it. If a is greater than 0, that means a is positive, then the parabola opens upward. And I think you figured that already. And if a is less than 0, the parabola opens downward. So that's one thing that we look at, is a positive or negative? And if it is positive, it opens upward. If it's negative, it opens downward. Now, let's say a is greater than 1, or a is less than negative 1. There's a vertical stretch. Because again, just so you know, the absolute value of a is greater than 1. And we know that's a stretch. Now, if a is a fraction, which is all of this other stuff, then we have a shrink. Fraction, shrink, bigger than 1, absolute value bigger than 1, that's a stretch. And again, we're looking at a on all of these. Now let's look at c. If c is greater than 0, then it is translated up. C number of units. And if c is less than 0, then the parabola is translated down c units. So if you look at this one that we just did up here, c is negative 2. That's less than 0, so that's why it's translated down 2 from the parent function. Because you remember the parent function had a vertex of 0, 0. So it's important that as you're learning this material, you are quickly able to identify a shrink and a stretch, a upward opening or a downward opening, and whether it's translated up or down, excuse me. Okay? Learn those, because later on we're going to get to B and we'll learn some things from B. So what I would like for you to do for your practice problems is to graph the two that we didn't graph, take a picture of both sides of this notes page, and submit that through Edmodo, and that will let me know that you watched the video and actually filled in the notes page.